Problem 1 asks us, what is the definition of the derivative of the function f of x? So when we want the formal definition, right, the derivative is notated as f prime of x. I could also write that as df dx. These are equivalent, right? And this equals the limit as h approaches 0 of f of x plus h minus f of x all over h. So in the previous section, we asked for the definition of the derivative of f of a right at a specific point, and that's when we did a. But here we want to know in general terms, and so we leave everything in terms of x. All right, question 2 states, for this problem, let f of x be negative 3x squared plus 2x minus 8. And we want to use the definition of the derivative to determine the derivative of the function f of x. So now what we want to do here is we want to find f prime of x. So just like we did in the last section, we can actually simplify the difference quotient and then take the limit at the end. So that way we're not having to write limit a bunch of times. So f of x plus h, I'm going to plug in x plus h everywhere I have an x here. So it's negative x plus h squared, I have a 3 out front, let's not forget our negative 3, plus 2 times x plus h minus 8. And I'm going to go ahead and simplify this. So the first thing I'm going to do is I'm going to FOIL my x plus h. So I get x squared plus 2xh plus h squared. I'm going to distribute this 2. And then I want to combine any like terms that I have. So I see here I have a negative 3x squared. I'm going to have a negative 6xh, a negative 3h squared, and then there's nothing else that I can do, so I'm going to carry everything down. So now I'm ready to set up my difference quotient. So my difference quotient is f of x plus h minus f of x all over h. So here is everything that was f of x plus h. So negative 3x squared minus 6xh minus 3h squared plus 2x plus 2h minus 8. Now I need to subtract the original function, but I need to put this expression in parentheses because I'm subtracting the whole thing. So I have negative 3x squared plus 2x minus 8 all over h. So now if I look at this, everything without an x should go away. So I have a negative 3x squared and then a minus 3x squared. So those will add to 0. I have a positive 2x and a negative 2x. So those will go to 0. And then I have a negative 8 and a minus 8. So those will add to 0. And I can see that every other term that I'm left with has an h in it. So when I simplify this down, I'm going to go ahead and pull an h out front. So I have h times negative 6x minus 3h plus 2. And I can see that if I multiply the h back, I get back these terms all over h. These h's cancel, and now I've simplified it as far as I can go, so I can take the limit as h goes to 0 of negative 6x minus 3h plus 2, and so all I have to do is plug in a 0 for this h, and I'm left with negative 6x plus 2. And so that would be our final answer for part A. Part B asks us, we'll determine the slope of the tangent line to this graph at x equals 1. Well, since I have a function here, right, that represents the slope at any value x, now I can just repeatedly calculate slopes very quickly for as many values of x as they want to give me. So what this is really saying in these instructions is to find f prime of 1. And now there's no reason for me to start this process all over again because I've now found the general form of the derivative. So I can just say, well, that's negative 6 times 1 plus 2, and this gives me negative 4. Part C says we'll now determine the equation of the tangent line to the graph at x equals 1. So I know my slope is negative 4 from part B. I know that the first value of my point is 1 because that's where x equals 1. So now I have to find f of 1 in order to get the y value for that point. So if I plug in 1 into my function, I get negative 3 plus 2 minus 8. Negative 3 plus 2 is negative 1, and negative 1 minus 8 is negative 9. So that means my point is 1, negative 9. So now I'll put that into my point slope formula. So y minus a minus 9, makes that a positive, equals negative 4 times x minus 1, and this is where we can stop. The last part says, well, for what value on the graph does f of x have a horizontal tangent line? Well, we said that, or for what value of a, excuse me, doesn't have a horizontal tangent line. So we said the tangent line will be horizontal, right, when the slope is 0. So that means we need to set the derivative equal to 0. So f prime of x was negative 6x plus 2. We're going to set that equal to 0. And now when I add 6x to both sides and then divide by 6, which equals 1/3. So that means that the only value we found is when a equals 1/3, the graph will have a horizontal tangent line. Right? Another thing I could have done here is I could have said, well, let's write f of a, just another notation for yourself. We could have said, well, if I plug a into the function, right, I would get negative 6a plus 2, set that equal to 0, and you would still solve to get a equals 1/3. So either way would have been fine, but technically since the graph asked for a, we probably should have plugged in a first.